Hey yo, like, subscribe, all that stuff. I don't know, I said it at the beginning of the video this time. So, ha! Um, yeah, I guess today we're going to be learning about Schrodinger's cat and why it's nonsense and why it always was, apparently. So, I don't know. Let's watch, I guess, because I always like this thing, this thought experiment, and as far as I understand, it's it's an analogy of the Schrodinger. I don't know quantum physics, just saying, but as far as I know, it's the equation. Schrodinger's equation is the likelihood that something will happen, but Schrodinger's cat is like it ends up in the likelihood of what will happen. So we don't know if it's alive or dead inside the box, although it's probably alive, like 99.99999 etc. % chance it's alive. But we don't know until it collapses. Am I right? Maybe. Let's watch.
Imagine you have a cat in a box, but
Cats love boxes, bro. My cat is not in the box at the moment. No. Where is he? Oh, he's on the pillow. Alright. So, yeah.
the box is a trap.
Because it would have been easier to imagine that the cat was in a box if my cat was in a box, you know?
Imagine you have a cat in a box, but the box is a trap. There's a mechanism that releases sleeping gas, if and only if an atom decays. Except atomic decay is a quantum phenomenon. If we close this box and make no observations of what happens inside, then the atom is in what we call a superposition of being decayed and not decayed. Does that mean the cat is also in a superposition of being both asleep and awake? No, don't be ridiculous.
I like asleep and awake better than alive and dead. So, that's good.
Of being both asleep and awake? No, don't be ridiculous. Hey crazies, what we're talking about here is the infamous Schrodinger's cat experiment. And the
That
original
guy,
version is
Schrodinger's
much more
cat.
grim than the one I just described.
Yeah,
Thankfully,
I'm
it's just a thought experiment. No one has actually done this. It's infamous because trying to answer this question
I'm sure somebody's done this, like put a cat in a box and put sleeping gas in there. No, I don't think anyone's done that. Never mind.
always starts arguments, which was exactly the entire point of this hypothetical. When Erwin Schrodinger came up with the idea in the 1930s, it was meant as a critique of quantum philosophy.
Really?
It was never meant to be taken seriously. While quantum mechanics certainly works well on particles, we shouldn't assume that it also works on objects, animals, or people. At least that was Schrodinger's.
But to a small degree, though, like there's a non-zero chance that my hand can go through this desk. Non-zero. Really not likely, but that's what quantum physics teaches me. That there's a non-zero chance I could just fall through the floor. Oh, what the fuck? Yeah.
Take on it. But the fact that so many people took it seriously makes quantum mechanics seem extremely unbelievable. Whenever I make a quantum video, I inevitably get comments outright rejecting it. People claiming that physicists have somehow lost touch with reality. That they're spending too much time in a lab and need to go outside and touch some grass or something. That's not how it is.
Touching grass would be an interesting analogy as well. Somehow. I didn't think this through, never mind.
Though, quantum mechanics works. It's one of the most well-tested models we have. And there is a solution to the Schrodinger's cat problem. Several, in fact. You just need to understand some important fundamentals of quantum mechanics. 1. It's not really about size or scale. It's about isolation. Larger systems are just more difficult to isolate. Subatomic particles like electrons display quantum behavior all the time. Does an entire atom? Yes, but less often. We've seen quantum behavior in entire molecules under the right conditions. So clearly there isn't a hard boundary with size, but it does seem to get harder and harder to see quantum effects the larger we go. Which brings us to the isolation idea. In the Schrodinger's cat scenario, this box is assumed to be perfectly sealed. It's completely isolated from its surroundings, which seems pretty unrealistic for a box. Even if the box were air-sealed and completely sound-absorbent, the cat is still releasing heat, which would warm the box. But you know what? Let's give this thing the benefit of the doubt and say it's perfectly sealed. It's still not a quantum system. The
perfect box.
cat is made of billions, perfectly sealed. It's still not a quantum system. The cat is made of...
I wasn't scratching my ear, I was scratching my earlobe. Itches. Alright, hold on, let me go back a little.
Doubt and say it's perfectly sealed. It's still not a quantum system. The cat is made of billions of billions of billions of atoms, most of which are not isolated from each other in the right way, let alone the immediate surroundings inside the box. The cat is not a quantum object. It is either awake or asleep. No superposition. The same
Yeah, I'm saying it's an analogy, right? Yeah.
Argument goes for the sleeping gas. It's either released or it isn't, not both. But this begs the question, how can that be true if it's activated by a decaying atom? Well, the atom is also not quantum. 2, an observation does not require a person or even a conscious mind. It's a terrible word choice. There's this misconception that quantum...
See, that I don't get. That I never got. The observation. Like, I understand that if observed by anything, then particles turn into waves, or rather the other way around, particles and as particles. If you observe them, and if you don't, they go like waves. I understand the concept of quantum physics, I think. I just don't get any of the math, which is probably the most important part, so I guess I don't get quantum physics.
Entity? It's a terrible word choice. There's this misconception that quantum entities are particles when they're being watched and waves when they're not.
That's literally what I said. Okay, let's find out what it really is.
Called wave-particle duality. It's a gross misrepresentation of what's happening, though it has given us some pretty funny memes. This is not about people watching particles.
What's the meme?
Though it has...
That's pretty funny, actually.
Has given us some pretty funny memes. This is not about people watching particles. You're not changing reality by looking at it. Quantum physics is not magic. It's just statistics. I'll admit, though, statistics does kind of feel like magic sometimes, but I digress. The decay of a large atom is
Statistics feel like...
Feel like magic sometimes, but I digress. I'll admit, though, statistics does kind of feel like magic sometimes.
Statistics kind of feels like magic sometimes. Yeah, I see that. Like statistically, this is true, but if it doesn't happen, magic. That's what I think that means. Magic.
Times, but I digress. The decay of a large atom is completely random. The decay of a large collection of those atoms is predictable, statistically speaking. None of those atoms decayed because we looked at them, though. We only know about it because we looked. The atom would have decayed whether we looked at it or not, for one very important reason. Atomic decay emits stuff. The moment that emitted part, important reason. Atomic decay emits stuff. The moment that emitted particle interacts with anything in the surrounding environment, the quantum shenanigans are over. Could that be with a detector a human has access to? Sure. But the detector inside Schrodinger's box is not accessible to anyone outside the box. Still counts as an observation. It doesn't even have to be a detector. It counts if those emitted particles hit air molecules or the walls of the box. It all counts as observation.
So interaction then. Interaction, not observation. But everything, never mind.
All that matters is whether or not information about that quantum system is available. If it is, it's not a quantum system anymore. And I mean literally just available. Whether or not a conscious mind ever learns that information is completely irrelevant. And frankly, a physical model that only applies when people are around would be pretty useless. 3. Quantum...
That'd be pretty cool, maybe. Yeah. I think they would be pretty cool.
Quantum effects
Tell me in the comments if why it wouldn't be really cool. I forgot what I said. Okay, let's keep going.
are beyond the human experience, so your intuitions no longer apply. I am by no means trying to argue that quantum mechanics isn't weird. It's weird AF. But there's this prevailing idea that somehow human brains are incapable of understanding it. Richard Feynman once said this on camera, and a lot of other physicists have said similar things. I don't buy it though. I bet there's a lot of physicists who understand quantum mechanics quite well.
Yes, but also no, because science is always changing. So you can think you know something really well, and then the next day that just totally shifts. One day we might be like electrolytes. That was a reference, I'm sorry. I just wanted to make the reference because my hands were like this. Electrolytes. Alright, never mind. Back to this.
Understanding it is not the problem. Explaining it is. A lot of teaching is about meeting your students where they are. But like I said, quantum mechanics is beyond the human experience. There's no way to relate it to human life, so there's no way to meet students where they are. The explain it like I'm 5 thing doesn't work here. But just because something can't be explained to you that
ChatGPT does it kind of well, explain like I'm 5. Like sometimes if I don't get a concept, I ask it to explain like I'm in high school, because that's easiest. Like early college, late high school, that's the best understanding I've ever had. I don't know. Let's keep watching.
doesn't mean you can't work here.
Rewind a little.
But just because something can't be explained to you, that doesn't mean you can't understand it. It just requires a lot of experience. You need to spend years with it to understand. But just because something can't be explained to you, that doesn't mean you can't understand it. It just requires a lot of experience. You need to spend years with it before you understand it. You need to work with the math first, which is why a common motto in quantum mechanics is shut up and calculate. Also, intuition is never the primary goal of science. It's to have an explanation that matches reality. Usefulness is the goal. Any intuition we gain is just a bonus. And until next time, remember, it's okay to be a little crazy.
I'll remember that.
Gaius suggested that we rename the speed of light to the speed of causality. Technically, it's the maximum speed of causality. Cause and effect can occur at any speed lower than that.
This is irrelevant. But I feel like I should watch that.
But honestly, we've been calling this thing the speed of light for hundreds of years. Good luck getting anyone to change now. And thanks for watching.
You're welcome. Anytime. I like this channel, I guess. I never watched it before. I mean, I watched another video today, and that's why I was like, oh shit. Oh shit. Alright, so I'ma go, but I'll say to the end too. Like, subscribe. I don't know, do people say share anymore? Like, subscribe, and share? They used to, right? So just like and subscribe. I don't care if you share. But like and subscribe, because that's important. And I want to do something with this channel. I just want to, I don't know, occupy my mind, and hopefully, I don't know, whatever. Oh yeah, I was going to sign out with